if you like, you can, if you like, you can start already by loading your R Studio environment. And I'm gonna try today to to teach concepts while at the same time running script in R Studio. So it would be great if you can prepare your environment in R Studio. And I want to start also with recap, because we covered a lot of concepts yesterday, but I think it was time well spent, because SEM is all about understanding what's happening under the hood, as I said yesterday, because anything that you get, whether it's an error or some results that you don't understand or don't trust, or you're trying to improve the model fit or do something about your model, it's really, really important that you understand what's going on when you get these estimates. So my challenge today was to try to summarize everything we did in 3 hours in one slide, which is always a problem, but I'm going to give it a shot. And please, please, please feel free to stop me to ask questions if it's not clear before I move on to discussing model fit. All right, let's go started. So on the right is just a sample model that you can look at to remember the parameters and what they're called. So in this model, we have oh, sorry, I was on mute for a while. Remember, we talked about exogenous and endogenous variables. So here we have one exogenous, two exogenous variables, and one endogenous, two endogenous variables. Notice that the endogenous, one of them is a latent variable, that's a circle, and one of them is the observed variable, that's a square, right? And then, of course, we have the measurement model. So each exogenous variable is going to have the x's, and each endogenous variable is going to have the y's. Okay, so let's start the recap. So whether you're running CFA, which we're going to cover today, or SEM, so if you have structural paths, then it's SEM. If you just have a measurement model, it's CFA. Regardless if you're running CFA or SEM, what's going on in SEM is that you're trying to reproduce the variance, covariance structure of the observed data. So you have your observed data, which is the x's and y's, and they covary together, hopefully, right? Because if they don't covary together, then you might as well stop. There's nothing really to do. So you want to choose variables that have some covariance, because you're trying to find relationships between them. So you have the observed variance covariance matrix. That's just given. Once you have the data, you just one line command in RStudio, you can get the covariance and variances, right? That's the first thing. Now, the software tries to reproduce that matrix by creating what we call the implied model variance covariance matrix. And it does so simply by using the estimated model parameters. Okay, so so you have the observed covariance matrix, and then you have the implied covariance matrix, and it tries to just look at the difference. It tries to minimize the difference between these two. And remember, how do we get the model implied matrix? You just use the multiplication rule. So for if you for variance in the observed data, you have the variance of x1, for instance, variance x1. So we try to reproduce it in this matrix by recreating the variance of x1 using the model parameters. So the simple rule is, let's say this is x1 right here. So you take the loading squared, so lambda 1, and then the lambda 1 times the variance, which is phi 1, times lambda 1 again, because it's variance. So you have to square the loading. Okay, so it's lambda 1 squared times the variance. So we use two parameters here, lambda 1 and phi, or phi, which is the variance. Okay, then you look at the covariance of x1 and x2, and then you do the same thing. This is x1, this is x2, so it's going to be lambda 1 times the variance times lambda 2. right? So it's just math. You don't really need to know it, but I like to know these things so that you can understand where it's coming from in case there's a problem. Software will just create this model implied variance covariance matrix for you, and it calls it sigma theta. You know, theta is just a placeholder for any parameters that the model estimates. Now, what are those parameters? Remember, it's two things. If you have an endogenous variable, you look at the paths coming to it, the direct effects. All right, so for endogenous variables, we look at the paths, the lambdas, lambda 1, lambda 2, lambda 3. We also look at the